Okay, welcome to the 6.1 notes. So you're going to need your own paper for this. You may also want a graphing calculator or a calculator in general. On some of these problems, they're going to be helpful, but on some of them, they are not. So, but anyway, so we're going to do two more sections before finals, 6.1 and 6.2. Both will be taught over the video, but I will be in class to assist you should you need help with all of that. So we're going to start here with 6.1, and the title of 6.1 is called Properties of Exponents. And according to Mrs. Fulmer, you guys have already learned some of these. So hopefully not all of this is brand new, but I do think that we are probably going to go beyond what she did. So I'm going to be doing a lot of examples in this video. The best way to learn this topic is just to do a ton of examples and practice problems. So that's kind of where we're going with this, okay? But before we get to the algebraic part, let's just talk about what happens if we see exponents with numbers, okay? So first of all, we'll call this example 1, all right? And with this, if we've got something like 2 to the power of 0, okay, the first thing you need to understand is that the 0 is the exponent, 2 is what we call the base, okay? That's just vocabulary that we're going to be talking about a lot second semester, so I just want to make sure that we're clear. 2 is the base, 0 is the exponent, okay? And to kind of get an idea of this, I'm going to go to my graphing calculator here, and I'm going to do 2 to the 0 power, just to kind of see what we get out of it. And our calculator, the almighty calculator, says that we get 1, okay? Well, let's see what happens if we do 1.068 to the 0 power. Let's just see what happens with that. Okay, so we do parentheses 1.068 to the 0 power. Oh man, we get 1 out of that as well. How cool is that? Okay, let's do one more here. Let's see what happens if we take negative 15 to the 0 power. Let's see what happens. Negative 15 to the 0 power, and that equals 1. Okay, so what you're kind of seeing here is, you know, it doesn't really matter what we have as the base. Right here, the base is negative 15. Here, the base is 1.068. It doesn't matter what the base is. You're going to get 1 out of it. Okay, so the moral of the story here, and I'm going to put it in a star, is anything to the 0 power is 1. Okay, that's the big idea here, is anytime that you take an exponent to the 0 power, the answer is going to be 1. Okay, so I could do 0 to the 0 power. Oh, there's a domain error. We'll talk about that later. But like 2 to the 0 power, and 3 to the 0 power, and 4,528 to the 0 power. It does not matter. Anything to the 0 power is 1. Okay, so that includes if we have x to the 0 power. And if you have x to the 0 power, that's going to be 1 as well. Okay, so just if there's anything that you highlight, if there's anything that you take away from this example, anything to the 0 power is 1. It is not 0. So many of you want to put 0. It is not. It is 1. Okay. If you're interested as to why that is, we can talk more in class more specifically about the why of that, but it would kind of take a little bit too long to explain over this video. So we'll put that as, you know, I think that maybe it's just not good for the video, but if you want more, then I can give that to you, okay? Okay, so let's go on then to a different situation. We'll call this example 2, all right? And on example 2, let's see what happens if we take 3 to the negative first power. Let's use our calculator again, okay? So 3 to the negative first power, that's 0.333 repeating. Remember, Ms. Baucom does not like decimals, so we turn it into fractions. We go math, enter, enter, and we get 1/3. Okay, so 3 to the first power is 1/3. All right, let's see if we can do some more examples like this and see if we can find a pattern, maybe. Okay, let's see what would happen if we did 10 to the negative first power. Well, 10 to the negative first power is 0.1. If we turn that to a fraction, we get 1/10. Okay? Let's do one more here. Let's see what happens if we do 2 to the negative 2 power. Let's see. 2 to the negative 2 is 0.25, which turns out to be 1/4. Okay. Well, we could also, and I don't expect you to make this jump by yourself, but we could also say, well, that's the same thing as 1 over 2 squared, right? Because 2 squared is 4. So that's another way we could write it. Okay, and the pattern that I want you to recognize here is that when you've got something to a negative power, you're going to create a fraction, put whatever that is in the denominator, and put that power with it. So here, if we've got 3 to the negative 1, we're going to put it in the denominator, and we could put an imaginary 1 there if we wanted to, but we didn't this time. Okay, same thing here. 10 to the negative 1, put it in the denominator, and then put that power with it. This time it's a 1. You could have it or not. It doesn't matter. On this one, okay, we could have written it as 1 over 2 squared, put it in the denominator, keep the power, and that would give you 1/4, which is exactly what we've got. And the cool thing about all of this is that you could always check these in the calculator. Okay? But let's see, though, what happens if we take, like, I don't know, x to the negative 2. Okay, so we're going to take it, put it in the denominator, keep the power, but you make that power positive now. Okay, so putting it in the denominator basically eliminates the negative on the exponent. Negative exponents are not happy. Negative exponents don't like to be negative. Okay, I don't like for you to be negative in class, and I also don't like for you to have negative exponents. Okay, so moral of the story, when you have a negative exponent, okay, so this is the thing that we saw. A negative exponent, here's what I want you to do. You're going to put the term, sorry, you can't see, put the term in the denominator, and then make the exponent positive. Okay, and I'm gonna box that in because that's an important thought. You could highlight it if you wish, but that's the moral of the story here. Okay, so let's do a couple more just like that, just so we kind of get the idea of what's happening. Okay. All right, so like if I had 3 to the negative 3 power, all right, let's see. We put the term in the denominator, all right, and then make the exponent positive. Boom, just like that. And then you would simplify from there. And so that equals 1 over, well, if you didn't know what 3 cubed was, you could come to the calculator and do 3 cubed in the calculator to get 27. So this would be 1 over 27. Okay. And let's see what happens if we had negative 2 to the 4th, because this is interesting. When you have negative numbers as your base, you need to keep the parentheses there. You cannot get rid of the parentheses. It matters. Okay. So you've got here, put the whole term in the denominator. That's the whole term. And then make the exponent positive. Sorry, that should have been negative 4. I apologize. Negative 4 up there. All right, and so then we can say, okay, well, 1 stays 1 divided by parentheses negative 2 to the 4th. And that equals 16. Okay, so this is 1 over 16. All right. Let's do 2 more here. So if we did let's do this one first. If we did y to the negative 5th, it's very similar to this x to the negative 2. We put the whole term in the denominator. We make the exponent positive. okay? Let's say now, though, we had a negative in the denominator. So if I had 1 over y to the negative 3, then what I would do is I would take it and I would put it in the numerator and make it positive. So basically, remember, I've tried to get this into your head a little bit, but whenever you have a negative, negative means opposite, okay? So whenever you have a negative exponent, you're basically going to take your term and put it in the opposite place. So if it was in the numerator, right, I know that there's not a fraction here, but remember, everything can be put over 1 and it would be the same thing, right? So when it's in the numerator, you put it in the denominator. If it's in the denominator a negative, you put it in the numerator. And then, I mean, you could leave it as y cubed over 1, or you could just turn it into y cubed. Okay? So basically, when the exponent is negative, put it on the other side and make it positive. Okay? Beautiful. Okay, example 3. For example 3 here, okay, let's do parentheses 2 squared with the 2 on the inside times 2 cubed, okay? Now this example here requires that you have at least some knowledge of exponents in the terms of 2 squared is the same thing as 2 times 2, right? And 2 cubed is the same thing as 2 times 2 times 2. That's what an exponent means. It just means take that number and multiply that many times. Okay, so now we've got 1, 2, 3, 4, 5. So we really could write this as 2 to the 5th. And then from there, we could take this and we could say 2 to the 5th in our calculator, and that would give us 32. Okay? So what we're doing here is that really with example 3, we are expanding and then simplifying. Expanding, then simplifying. Okay? So the answer to this question here would be 32. And you could plug that into your calculator and check. Okay, but remember, the goal of understanding how to do it this way is so that when I give you a variable here in a second, that you can do it. Okay. Let's do another one with a negative, because negatives are interesting. Okay. Let's say we had negative 3 to the 3rd times negative 3. And notice where your exponent is here, okay? It's on the inside, all right? So what we've got going on here is, remember with order of operations, right? Order of operations says that we have to do exponents before we can multiply, okay? And so the reason that this translates here is when you've got this negative 3 to the 3rd, what that means is that you have to do 3 to the 3rd first, then multiply by that negative. Okay, so if I were to write that out, okay, we've got 3 to the 3rd first, so that's 3 times 3 times 3, but then make it negative. So there's really only one negative in that case. All right, and then we still have this negative 3 out there. Following that? Okay. So really what we could do now is we could say, all right, well, anytime that you take two negatives, it's going to create a positive, right? So this really could be written as 3 times 3 times 3 times 3, which is equal to 3 to the 4th. And then we could go to our calculator and we could say, all right, 3 to the 4th is equal to 81. Okay? Main thing about this example is that you understand that you have to apply this exponent here before you can apply that negative out in front. Okay? That one might be something that you ask questions about in class if that's still a little bit unclear. Okay. All right. So now let's look at an example where it's like 10 to the fourth times 10 to the negative 6. Okay? So let's just do one thing at a time, all right? 10 to the fourth is like 10 times 10 times 10 times 10. Okay? That's what 10 to the fourth means. Now, 10 to the sixth, okay, that's where you take the whole term, you put it in the denominator, and you make it positive. So those rules still hold here. Okay? So now if we write this out, we've got in the numerator the same thing, 10 times 10 times 10 times 10, divided by, and then we've got 6 tens. 1, 2, 3, 4, 5, and 6. Okay? And you could multiply all those out, but hey, watch this. Okay? Remember, 10 divided by 10 in general is equal to 1, right? So if you've got 10 divided by 10, that's 1. 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 So really you're left with 1 in the numerator, and then you're only left with 2 tens in the denominator. So you could write that as 1 over 10 squared. And then you know that 10 squared is 100. So your final answer to this problem here is 1 over 100. Write it out. When in doubt, write it out. I'm going to put that in a star here. Write it out. And I'm going to highlight it. Because you guys like try to find shortcuts. And there are shortcuts to these things. And if you notice the patterns, that's great. I'm not saying that you can't use them. What I'm saying is that a lot of times you guys get the rules mixed up or the shortcuts mixed up, and then you end up getting things wrong. Okay, so I really recommend that you don't do that. Okay, let's do some more examples. We need more. Let's say that I gave you x cubed times x squared. All right, now I've gotten a variable involved, but guess what? They behave exactly like numbers do. Okay? So if we've got x cubed times x squared, that's the same thing as x times x times x, right? That's the x cubed. And then I've got x squared, which is x times x. So really here I've got 1, 2, 3, 4, 5. That's x to the fifth. And I want to take a moment here and pause because this is kind of a misconception among some people, okay? X times x times x times x times x, that's x to the fifth, okay? But x plus x plus x plus x plus x, that is 5x. And those two things are not equal. X to the fifth and 5x are not equal, okay? Let me give you an example. Let's say that x was equal to 2, okay? 2 to the fifth power, that's 32, okay? But 5 times 2 would be 10. And 32 is obviously not equal to 10. So what you need to understand is that when you're multiplying, repeated multiplication is an exponent. Repeated addition, that's when you put the number out in front and multiply it. Okay? Common misconception. We're going to revisit that a lot. Okay? Okay, so now what if we had x cubed times y squared? So now we've got different variables. Okay, well, so if we're not sure, let's write it out. We've got x times x times x times y times y. And just like with combining like terms or adding things, you can't multiply things that are unlike either. So while writing it out is helpful in most cases, the answer to this problem is just the question itself. It's just x cubed y squared. There's nothing that we can combine here. There's nothing that we can do with that. So we just leave it. Okay? Oh man, so many little things. Okay, let's do another example. Yep, let's keep going here. So we've got what if I did something like 2 to the 5th divided by 2 squared? Okay, well, when in doubt, write it out. So 2 to the 5th means 2 times 2 times 2 times 2 times 2. And 2 squared is 2 times 2. And just like we did up here with the tens, when there's something that's the same on the top and the bottom, that simplifies to 1. You guys call it canceling, which is fine. It's not the correct term, but it's fine. It works. Okay, so 2 over 2 goes away. 2 over 2 goes away. Those simplify to 1. So really, you're just left with 1 in the denominator. And anytime you have a 1 in the denominator, we can kind of just ignore it. So really, we've got 1, 2, 3 2's, which is 2 cubed. And 2 cubed is like 2 times 2, which is 4, times 2, which is 8. So the final answer to this problem is 8. Okay? And you could have just plugged this straight into your calculator and gotten 8, right? But the whole purpose of this is to be able to understand these rules so that when we get to things with variables, we can work with them still. Okay? All right, what if I did, this one's interesting, negative 5 to the 8th divided by negative 5 to the 4th. Okay? And similar to what we did up here with these negative 3's, okay, because order of operations tells us we have to do the exponents before we can do the negatives. Okay, so let's write this out. We've got a negative, but then we've got 8 5's. So 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 5's. And then on the bottom, we've got the negative again, right? But then we've got 4 5's. 1, 2, 3, 4. Okay? And if it's on the bottom and on the top, it simplifies to 1, including these negatives, right? And you know in general that a negative divided by a negative, that's going to be a positive, right? Okay, so the negatives simplify to 1. Those 5's simplify to 1, simplifies to 1, simplifies to 1, simplifies to 1. So really you're left with 1, 2, 3, 4, which is 5 to the 4th, and I'm going to need a calculator for that one because that's going to get pretty big. 5 to the 4th is equal to 625. So your final answer to this one is 625. Okay? Again, we're just going to continue doing just a bunch of examples. Okay? All right. What if, let's go to some variables now. What if I gave you y to the 6th divided by y to the 7th? Okay, let's write it out. Y to the 6th means I've got y times y times y times y times y times y. We've got 6 of them. Okay? And then I've got 7. 1, 2, 3, 4, 5, 6, 7. And now if I've got the same thing on the top and on the bottom, then that means that they can just go away. Go away, go away, go away, go away, go away, go away. And all I'm left with is this lonely y, but notice it's on the bottom. So that means you can't just bring it to the top because it's by itself. You have to keep it on the bottom there. So your final answer for that one would be 1 over y. Alrighty? Great. Okay, let's go to a different kind of idea. Same concept, but a different kind of idea here. All right, we'll call this example 4. I know that I'm doing a lot of mini examples inside of them, but these are just the types. Okay, so for example 4, let's say that I had in a parentheses 7 cubed squared. Okay? So now I've got 2 exponents. Whoa, craziness. All right, well, like if I told you x squared, that would mean x times x, right? You just take what you have and write it twice. So the same concept's going to be applied here. If I've got 7 cubed squared, then that means that I've got 7 cubed times 7 cubed. I've just got 2 of them, right? That's the idea of something being squared. You just have 2 of them, okay? And now we can write it out further because 7 cubed is like 7 times 7 times 7. And 7 cubed is 7 times 7 times 7. And then you count them up. You've got 1, 2, 3, 4, 5, 6 of them. So that turns out to be 7 to the 6th. And then you go to your calculator and you say, okay, 7 to the 6th, which is a really big number. Let's see, 117,649. Holy moly, things get really big really fast. That's kind of fun though. Okay. So again, you're probably like, Ms. Baucom, I could have just plugged that into my calculator. You're right, you could. But then what if I gave you this? What if I gave you p squared to the 5th power? P squared to the 5th power, like that. Okay? So deal with this outside exponent first. That means that you have 5 p squareds. So p squared times p squared times p squared, p squared, p squared. Okay, so there's 1, 2, 3, 4, 5 of them. Now we can go inside our parentheses and say, okay, well, p squared is p times p. That p squared is p times p. That one is p times p. That one is p times p. And the last one is p times p. Okay, and you could probably do this all in one step. If you were really comfortable with all of this, you could do it all in one step. Okay? And then we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you have p to the 10th. And that's where you would stop because you don't know what p is. Okay? Kind of, hopefully. Not that you can give me feedback right now, but at least it's something. Okay. So now what we're going to do is we're just going to combine all of those rules and just do a bunch of examples. Okay? So let's do x to the 4th in a parentheses to the power of -2. Okay, so deal with the outside exponent first. We deal with this -2 first. So anytime you have a negative exponent, you're going to take the whole quantity, which is x to the 4th, and then you put it in the denominator and you make the exponent positive. Okay? Then we use the rule we just learned and say, okay, well, if we've got x to the 4th squared, then that's like 1 over x to the 4th and x to the 4th. And then we can write that out even further and say, okay, well, that's the same thing as 1 over 1, 2, 3, 4 from this x to the 4th. And then 1, 2, 3, 4. And then you can count them up. And you've got 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. 1 over x to the 8th. And that's where you would stop. You can't do anything else. And by the way, 1 over x to the 8th is not equivalent to x to the 8th. They're very different things. It would kind of like me saying to you 3 is the same thing as 1/3. And that's not the same thing. Okay? So make sure that wherever your x's are, you stay there. You can't just bring these up top. All right? Doesn't work like that. Okay? This one's interesting. What if I gave you 5 to the -3 to the power of 5? Okay, well, deal with the outside exponent first. That means I have 5 of these. So that means I have 5 to the -3, 5 to the -3, 5 to the -3, 5 to the -3, and 5 to the -3, just like that. Well, whenever you have a negative exponent, you take it, you put it in the denominator, you make it positive. And so that's what we're going to do to all of these. Take it, put it in the denominator, make it positive. Put that term in the denominator, make that exponent positive. Term in the denominator, make the exponent positive. Term in the denominator, make the exponent positive, right? All right, now let's write it out. Here we go. 1 over 5 times 5 times 5 times 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 1 over 5 times 5 times 5. Tedious, not difficult, but tedious. Guess what? So is life. Get over it. Okay? And so now let's count them all up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you know what? I think I'm just going to leave that as 1 over 5 to the 15th. If you wanted to, you could go figure out what that was, but that's going to be a really large number. Okay, so on big numbers like that, I'm okay if you leave it as something like that. Okay? Tedious, not hard. Okay, let's do some more. Let's just keep going. I'm going to call this now example 5, though, because now this is just a hodgepodge of all kinds of different things. So this is the summary of basically everything we've done, and we're just going to keep doing examples. Okay? So on this first one, let's do negative 1.5y squared. Okay, so work from the outside in. Let's work on what this 2 means. Well, if you've got that squared, that means that you have negative 1.5y times negative 1.5y. Okay, and so you just multiply. Negative 1.5 times negative 1.5 is a positive 2.25. You could just use your calculator for that one. Okay, and then if you've got y times y, that turns out to be y squared. And then there's nothing you can do. You just stay there. Stay there. Okay? Beautiful. Okay. What if we had now the quantity 3d over 2d cubed to the 4th? Okay? Like I said, deal with the outside exponents first. So that means we have 4 of those. So we've got 3d over 2d cubed, 3d over 2d cubed, 3d over 2d cubed, and 3d over 2d cubed. So we've got 4 of them. That's what that power of 4 means. Okay. All right. Now, before we go listing these things out, okay, let me show you something that's going to happen. So I'm going to come over here and do some work. 3d over 2d cubed looks like this, correct? And if you notice, they have something in common on top and bottom. They have a d, so you could essentially, simplify those out to 1. So really, all of these would simplify to 3 over 2d squared, right? So we could simplify before we even did the multiplication here, right? All of those would simplify down to 3 over 2d squared, which is helpful to us, okay? So now we can say, all right, well, you've got 3 times 3 times 3 times 3. And if you plug that into your calculator, you're going to get 81. All right? So then we've got 2 times 2 times 2 times 2. That's going to be 16. And then we've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8 D's. Okay? Now, and that's where you would stop. You can't simplify 81 over 16. The d to the 8th's got to stay in the bottom. All right? You could have written all this out and then simplified in the end. Regardless, you have to simplify at some point. Make sure everything is simplified before you circle your answer. Okay? Beautiful. Okay, let's keep going with some examples here. Let's do 5 to the negative 1 divided by negative 9 to the 0. Oh boy. All right. Lots of little things happening here. Okay? So let's first deal with this top part. Okay, you've got 5 to the negative 1. All right, well, that looks like 1 over 5 to the first, right? Okay. Now we've got negative 9 to the 0 power. Well, anything to the 0 power is just 1, right? But you still got this negative out here, so you still have a negative 1 in the denominator. Oh boy. And so now you can just multiply, right? So we've got 1 over 5 to the first power is 5 times negative 1 is negative 5. The answer to this one is negative 1/5. It's crazy how, different they look, and then they clean up to be something way nicer. Oh boy, lots of different rules. Okay, what if I gave you 5x squared times y times 2x to the 4th y to the 6th? All right, well, let's write it out. Here we go. We've got, just on this one, 5 times x times y. And then this is 2 4x's and 6 y's. Okay? And now we just combine what's alike. 5 and 2 are alike, so those multiply to be 10. You've got 1, 2, 3, 4, 5, 6 x's. And you've got 1, 2, 3, 4, 5, 6, 7 y's. And that, dear children, is where you would stop. There's nothing else you can do there. You just multiply it all out. Some of you might start to see a pattern. And you might see, oh, Miss Baucom, I don't actually have to write these out. I see what I can do. Okay, great. Go for it. But if you're wrong, remember, the more work you show me, the more partial credit I can give you. So if you're seeing the shortcut, that's great. Just make sure you're doing it correctly, because if you do it wrong, I can't give you partial credit. Okay? Just remember that. Alrighty? All right, let's keep going. I've got 1, 2, 3, 4 more. I know this is hard, but you're fine. What if you've got z to the 4th times z squared over 2z to the negative 5? All right, just take it one thing at a time. Just look at the first thing you're given. Z to the 4th. Z to the 4th is z times z times z times z. Okay? Z squared is another 2 of them. Z times z. Divided by, you've got a 2 in the denominator. Okay? Well, z to the negative 5, if it's in the denominator, you need to move it to the top to make it happy again. So then you've got z to the 5th up top. So you've got 5 more z's up here. 1, 2, 3, 4, 5. 5 z's up top. Okay? So now let's simplify. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You've got z to the 11th divided by 2. And that's where you would stop. There's nothing more you can do there. Holy cow. We didn't even know we didn't know this. Awesome. Okay. Here we go. What if I gave you negative 5 p to the negative 3 to the 3rd? Okay. So deal with what's on the outside first. If we've got something to the 3rd power, then that means we have 3 of them. So negative 5p to the negative 3rd, negative 5p to the negative 3rd, and then negative 5p to the negative 3rd. Okay? Now I like this example because it does something interesting. Do you see how there's 2 things here? You've got a negative 5, and then you've got p to the negative 3rd. Okay? The only thing that the exponent of that negative 3 applies to is the p, right? Because you have to do exponents before you can do multiplication, which means that this negative 3 here does not apply to the negative 5 at all. It's not even its friend. It's somewhere over there. So what this means is when you go to move this to the denominator, that's the only thing that goes. Okay? So you've got negative 5 over p cubed. That's what that term simplifies as. Okay? And the same thing up here. You've got negative 5 over p to the 3rd. And then negative 5 over p to the 3rd. Just like that. Okay? So now we can go through and we can say, all right, well, negative 5 times negative 5 times negative 5, that's going to be negative 125. Okay? And then I'm going to assume that you can write this out on your own, or you can visualize it, all right? P cubed is P times P times P. P cubed is P times P times P. And P cubed is P times P times P. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 P's. So this turns out to be P to the 9th. And then you stop. There's nothing more you can do. That is it. That is all. Okay, great. 2 more here. Hang on to me. You're doing great. What if we had negative W cubed over 6 all to the negative 2? Oh my gosh. Okay, well, so we work from the outside in, right? Okay, now this one's interesting because you're like, all right, well, we're going to have this in a denominator, right? Because when you have a negative exponent, you put it in the denominator and then you make the exponent positive. Well, it's already a fraction. Okay, well, look at it this way. The W cubed would go to the bottom, and then the 6 would go to the top, right? If each one of those was raised to that power of that negative 2, that's what would happen. The W cubed would go where it's not, and the 6 would go where it's not. So when you have something like this, this is the same thing as saying negative W cubed, nope, just kidding, negative 6 over W cubed squared. When you have a negative and there's a fraction on the inside, flip the fraction, make it positive. Okay, you might need to rewind that and listen to that again. But now that this occurs, okay, well, if something's squared, then that means that I just have 2 of these. So negative 6 over W cubed times negative 6 over W cubed, just like that. And now we can multiply. Negative 6 times negative 6 is a positive 36, okay? And then I've got 1, 2, 3, 4, 5, 6 W's. W to the 6th. And that's where we would stop. That mess turned into that. How crazy is that? So crazy. All right, one more. This kind of encompasses almost every single one, every single rule. Okay? What if we had the quantity 2x to the 0 power over 6x to the negative 3y. And then that quantity is raised to the 3rd. Okay. Now, I know that I've been telling you to deal with the outside exponents first, and you can. But I want to show you what happens if you simplify before that, right? What's on the inside, you can deal with what's on the inside of the house first. You can clean up the inside of your house before you clean up the outside, right? So I'm going to show you what it looks like if you choose to do it that way on here, okay? So we still have whatever's on the inside, it's still cubed. So I'm going to create a skeleton like that, but I'm going to clean up what's in here, okay? X to the 0 is just 1. So 2 times 1 is just 2. So we can kind of basically ignore the x to the 0 there because it's just 1, okay? Then 6x to the negative 3rd. Okay, well, the 6 has got to stay down there, right? X to the negative 3rd, those x's are going to come up top. They're not happy. They have a negative exponent, so that means I'm going to have x cubed up here now. And the y can stay down there. The y is happy. It can't combine with anything, okay? And then there's one more thing you can do. You may not see it, but 2 over 6, that simplifies to 1 over 3. So really, we've got 1x cubed over 3y to the 3rd. Okay? So now what that means is that we've got x cubed over 3y times x cubed over 3y times x cubed over 3y. And then you could write it out from here, or you could see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 x, x to the 9th. Don't make that mistake. X to the 9th. And then 3 times 3 times 3, that's a 27. Y times y times y is a y cubed. And then that's where you would stop. There's nothing more you can do there, okay? It is really, really easy on these to make little mistakes, okay? I recommend if there's a part of that you need to rewatch, go rewatch it. That's the beauty of a video. Okay, if you need to rewind it, go do that. The videos online may or may not be helpful too. So I would encourage you to start working on some practice problems and then have questions ready for me on Monday. Okay?